Okay, this is the first video lesson uh, from chapter 1, that is chemical reaction and equation. Now, before we discuss anything, we have to find the meaning of chemical reaction and then the meaning of equation. Okay, we'll try to find the meaning of chemical reaction and equation indirectly. So let us discuss change. Change in chemistry we are talking. In chemistry, we can classify change into two types: physical change and chemical change. Okay, now when the change is called physical and when the change is called chemical, for that condition is that in physical change, in physical change, formulas should not change. Formulas should not change. Only physical states should change. So the change in which formula is not changing, only physical state is changing. For example, solid is turning into liquid or liquid is turning into gas, but the formula remains same, then that kind of change is called physical change. So physical change cannot produce new substance, can't produce new substance. Now, in chemical change, the most important criteria or characteristic of chemical change is that formula must change. Physical state changing or not changing does not matter. But the formula of the substance involved in the change must be changing. Then only the change is called chemical change. So in chemical change, formula must change. Formula must change. Physical state may or may not change. Physical state is not important for chemical change. Physical state may or may not change. And whenever chemical change take place, then always new substance will be produced, because whenever the formula changes, then the new formula which will come out will produce new substance. So chemical change always produce new substance with new formula. Okay, let us take some example. So example of physical change and example of chemical change. For example, ice, which is solid, if you hit, then it turn into water, which is liquid. So here something is changing. What is changing? Your ice is changing into water. Now this change is example of physical change. Why it is physical change? Because you see what is happening. Your solid is turning into liquid. That means your physical state is changing. Physical state changing. Then if you see what is the formula of ice, ice formula is same as water because it is same thing, and water formula also H2O. So this formula is same. So in this change, what is changing? Only physical state. Solid is becoming liquid, whereas the formula of ice and water is same. That means formula is not changing. So this is satisfying the definition of physical change, because physical change is that change in which formula should not change, only physical state will change. And here water is not a new substance, because ice and water both are same substance because they are having same formula. Only the physical state is different. Okay, if you want to take example of a chemical change, then let me just suppose a hydrogen gas, when it burn with oxygen, then it produce water plus energy, that is heat. Okay, let us write this one in the form of a formula. This I'm just using words. So hydrogen gas formula is H2O. Oxygen formula, sorry, hydrogen formula is H2O, sorry, H2. Oxygen is O2. So when these two combine, we get water and energy in the form of heat. Now, here you see what is the formula of hydrogen, H2. So this H2 is becoming H2O. That means your formula changing. Formula changing. Or you can think this also, this O is becoming H2O. So this also the formula is changing. So if you study this change, then you'll find that your formula before the change and after the change is not same. Before change, hydrogen formula is H2, and after change it is O2. And when these two combine, a new formula is coming, H2O. Okay, this H2O contains same atom, but formula is new. That's why water is a new substance produced here. So this kind of change in which formula is always changing, physical state does not matter, this kind of change is called what? This is called chemical change. So this is example of chemical change. Now chemical change you can write like this or you can write like this. Okay, before that, chemical change, chemical change, chemical change is also called chemical reaction. So our chapter name is, if you see the name of the chapter, it is chemical reaction and equation. So chemical change is, chemical reaction is nothing but it is just another name for chemical change. So I'll repeat, chemical reaction is another name for chemical change. So chemical change is also called chemical reaction. So what is chemical reaction or what is chemical change? It is same thing. It is a change or it is a process in which formula must change. That means always some new substance should be produced. Why we are saying new substance? Because formula, when formula changes, always new substance will come out. Okay, now, so this is example of chemical change, or it is an example of chemical reaction. Now whenever you write chemical reaction in this way, so this is, okay, this I can say this is chemical reaction. Example is this. Now this chemical reaction, when you write like this, means using symbol and formula, then this chemical reaction is called chemical equation. So chemical equation is the method by which chemical change is represented by using the formula of the substance involved. So if suppose there's a question and the question is asking give chemical equation. So if the question is give chemical equation, and if you write like this, you'll not be getting any mark, because this you're writing word only. So chemical equation means you have to represent using the formula. Then only it is called chemical equation. So chemical equation, uh, whatever is on the left side. So chemical equation, how it is represented. To represent chemical equation, we use formula and separate reactant and product with this symbol. So the basic principle of writing chemical equation is that whatever substance we have on the left side, suppose let's take one example. Suppose carbon, when it combined with oxygen, it produces carbon dioxide and a lot of energy is released. So this is a chemical equation. So it's chemical equation, generally we use arrow sign. Sometimes we can use equal to, but generally arrow is used. So whatever substance we have on the left side, that is before the reaction, are called a reactant. And whatever is coming out is called product. Okay, so this is the general way to write chemical equation, but there are some rules. To make chemical equation more informative, we can add information other than formula. So what information we can add in chemical equation to make it more informative? We'll see on the next page. Chemical equation can be made more informative by adding following information. So what information? We can mention the physical state of reactants and products. Can be mentioned in following format. For example, if any substance in the chemical equation is the physical state is solid, then to represent that chemical or that substance is solid, what we can do, we can write bracket and then we can make small s. Similarly, if it is liquid, then in bracket we can write small l, that represent that chemical or that substance or that reactant or product is in liquid state. Similarly, for gas, we have two options. We can write G, but sometimes we write like this. We put upside arrow. So upside arrow also meaning is gas. Okay. Then sometime we use some reactant in the form of solution, and generally we make solution of the chemical in water. So to represent the chemical in water solution, water solution is also called aqueous solution. This is used mainly for the reactant. This solid liquid gas can be used for both reactant and product. We use bracket and we use AQ. So whenever after any reactant, if AQ is mentioned, that means that chemical is in the form of a water solution. That means that chemical is dissolved in water, and that water solution is used in the chemical equation. Okay, sometime a product which is formed may be insoluble, generally in water. To represent any product insoluble in water, we use a symbol pointing downward arrow. So insoluble. Insoluble in chemistry is called precipitate. So in this way, we can make your chemical equation more informative if we can provide the more information, like you can mention the physical state of the substance, that is of the reactant and product. We can also mention if any solution is used or not. We can also mention if any product is formed, if it is insoluble, then we can use this arrow. Similarly, we can also mention energy. Energy here means heat change in chemical equation. And how heat change? Now, change meaning sometime heat may be needed in chemical equation, and sometime heat will be released. So change has two meaning. So heat change. So change meaning heat is needed or required, and some chemical equation, the heat will be produced or released. Okay, so these two conditions. So let us suppose when heat is when heat is required, any chemical equation which need heat to undergo the reaction, then how that heat is represented. When heat is required, another word we can say absorbed, or we can say needed, in chemical equation, then write heat along with reactant generally. So in a chemical equation, if heat is required, and then you can write like this: reactant plus heat product. So whenever heat is on the left side, that is along with the reactant, that means this heat is required. That heat, yeah, we have to supply this heat, and only the reaction will take place. Okay. Sometimes this can be written like this also: reactant product. Sometimes heat is written above the arrow. Now, if it is above the arrow also, you consider it is with the reactant. That means this heat is required. Above the arrow also, you consider required. But to make it more twisting, sometimes if they want to twist, then they may write like this: reactant, product minus heat. So this heat is written along with the product, but don't consider that this heat is released in the reaction because of minus sign. So heat, always you have to consider in plus, with plus sign, where it will be. So this minus heat, if you think plus, that means it is. So this also is same thing. Okay, sometimes it may be twisted. Similarly, if when heat is released, release, or we can say given out, or produce in chemical equation, then the rule is then write heat along with product. So for this, the rule is reactant, product plus heat. So whenever heat is written along with the product, that meaning is that this heat will be released in the reaction. And this one, if they want to twist, they may say reactants minus heat equal to product, or give product. So this heat is along with the reactant, but it is with negative sign. So this heat means, if it is positive means it will be here. So with negative sign also it will be this category only. Okay, so this is point 2. Now one more point we can add. Other condition involve in the reaction, like pressure, catalyst, etc., can be indicated above or below arrow sign. Okay, after this, let us see one law called law of conservation of mass. What this law is telling, don't think that chemical reaction is the only reaction. There are other reaction which is there in your textbook, but it is under that chapter is deleted. That is sources of energy. So there is another type of reaction called nuclear reaction. So this law of conservation of mass is not valid, or it is not correct for nuclear reaction. It is only valid for chemical reaction. So this law is valid for chemical reaction. That is, this law is not valid for nuclear reaction. What this law is telling? Law is telling that whenever chemical reaction take place, then total mass of reactant and total mass of product must be equal. So as per this law, in chemical reaction, total mass of reactant must be equal to the total mass of product. And to make this law correct, what we have to do, chemical equation has to be balanced, has to be balanced. Then only these two will be equal. Okay, in some cases without balancing also it will be equal, because some chemical equation without doing anything it will be balanced without adding any number, some cases. But whenever you are balancing a chemical equation, that means both side in reactant and product, number of same type of atoms should be same. So why balancing we are doing? We are doing balancing just to make sure that this law is correct. That means just to make sure that total mass of reactant and total mass of product is same. For that, balancing is needed. Okay. So for balancing of chemical equation, there is no proper formula that you follow that formula, your balancing will be always correct. There is no 100% correct rule also. So just you have to keep on trying. That means it is done by heat and trial method. So balancing of chemical equation is mostly done by heat and trial method. But during doing heat and trial method, some hints, some tips can be remembered so that balancing work become little easier. So for balancing chemical equation, we say there is no proper formula, there is no proper rule by which method you should balance. So you have to see the numbers logically and you have to think what number to add so that the number of atoms, same type of atom, both side of the chemical equation, that is reactant and product, will become equal. So your balancing main aim is to make number of same type of atom equal on both sides, not one but all different types of atom on both sides of the equation, that is reactant and products, should become equal. So for that, some tips we can follow. Now tips, as per our textbook, what tips is mentioned in our textbook, and that will not follow that only, so we'll be following little different tips here as per textbook. If you want to do balancing, then you do balancing or you start balancing from that formula which is more complex. That means you start with the formula which contain largest number of atoms. So as per the textbook, start balancing start balancing with complex formula first. That is, start balancing that formula which contain largest number of total atoms. Okay, this is the textbook rule. So we'll not, this already you'll be knowing, you can utilize this rule, but we'll be talking a new rule. That new rule, if you like, you can remember, otherwise you can follow textbook also. So this new rule is from other source. Some textbook this rule also is explained, other source. So in other source or other way of balancing is that while balancing you have to follow some sequence. That means what to do first, which atom to do misbalance first, which one to do second, which one to do third. That rule we are going to write. Start balancing of atoms in following sequence. Okay, so first you check you have any metal in the equation or not. If any metal is there, then you balance the metals. If you have more than one metal, then both the metal you do balancing first. After finishing all the metal, then second you do balancing of non-metals. Now when you do balancing of non-metal, here condition is when we say non-metal, but in that non-metal you other than O and H, non-metal other than O and H. So if there is any non-metal other than O and H, then that non-metal should be balanced in second step. Then third step, you do balancing of oxygen if it is present in the equation. If not, go to fourth step. In fourth step, you do balancing of hydrogen if present in the equation. Now, while applying this rule, what care you should take? Okay, suppose you have balanced metal on both sides and you are going to non-metals. Now, when you finish non-metal balancing, again you go back and check whether metal balancing that you have done before is still balanced or it is disturbed. If it is disturbed, then again you do, again come here. Okay, so after this, when you come here, so when you balance this, again you start check whether this is disturbed or not. This is disturbed or not. If it is disturbed, do the balancing again. So this rule you have to follow. Whenever you do, suppose when you do finish this, again all you check. Because sometimes when you do any of that, then there's a chance that other may get disturbed. So you have to check. Whenever you do balancing any stage, you check starting from beginning. So on this principle, we'll be practicing some balancing from our textbook question. So on page number, on this is exercise question we'll be trying. So on page 15, there's question number 6. Balance the following chemical equation. A HNO3 plus CaOH2 CaNO3 then H2O. Now suppose any equation, if it is very simple, then without following any rule, quickly you can balance. So if you can balance without following any rule, that is good. But if you are struggling, you're taking a lot of time, then follow this sequence that we are talking. So here, as per the rule, just now we discussed, first rule, we have to check any metal is there in this equation or not. So the metal is here, this one, calcium. So first we have to balance calcium. And after finishing calcium, then we have to see we have any non-metal or not. Now non-metal means other than ONH. So other than ONH, non-metal, if you check, then you have nitrogen. So second, you have to balance nitrogen. Then third step is oxygen, but check you have oxygen. Okay, oxygen is there, O is there. So third step, you have to balance oxygen. And most of the time, when you balance oxygen, the last one, hydrogen, will be automatically balanced in most of the case, not all the case. Okay. Now let us check one by one. Calcium. Okay, here calcium. Okay, whenever you're doing balancing, you have to add some number, and that number you can add only in the beginning. Only in the beginning. That is left side of the formula. Left side. In the middle or right side, you cannot add any number, because that number which is in the middle or right is the part of the formula. So whenever you do balancing, your formula should not be disturbed. So for balancing, you can choose a correct number so that both side atoms become equal, but that number you can write only on the left side. Left side, left side, left side. So this calcium is known number means 1 calcium. This calcium also known number means 1. So calcium is balanced right now. Okay, so calcium don't do anything. Next, nitrogen. Now here nitrogen, look at this bracket 2. This means this 2 is for this also, it is for this also. So this nitrogen is 2, but here nitrogen is 1. So to make this nitrogen also 2, you write 2 here. Now check, nitrogen is 2. This nitrogen is also 2. Now again check calcium, since you are doing nitrogen here, and here calcium is not disturbed because you're not putting any number here. So just make a habit that when you balance that, just check this is disturbed or not. So here it is not disturbed, but make habit of checking. So after nitrogen, next is oxygen. Now here your oxygen is 2 into 3 is 6. Here your oxygen is 2. So together your oxygen is 8. Now let us check on other side. Here your oxygen is 6, and here your oxygen is 1. So altogether it is coming 7. So this is not balanced. So what we can do, if you can put 2 here, if you can put 2 here, then this oxygen will become 2, and then 6 plus 2 you'll get 8. So now oxygen is balanced. Now when you're balancing oxygen, you can just quickly check other thing are disturbed or not. Calcium, 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 1 1, fine. Nitrogen, this nitrogen is 2, and this nitrogen is also 2, fine. Oxygen, just now we balance, we can recheck. This oxygen is 2, and this oxygen is 3 into 2 6. So 6 plus 2 8, and this side, this oxygen is 3 into 2 6. This oxygen is 2, so 6 plus 2 8. So now all three are fine. Now hydrogen, let us check. So hydrogen here, this hydrogen is 2, this hydrogen is 2, so 2 plus 2 4, and this is 2 into 2 4. So hydrogen, no point of doing anything, is automatically balanced. Now you should not write like this. Okay, you should cancel. Okay, with pencil you can clean. This is not a part of the answer. So answer is this one. Or we can do one thing. This one I think you can practice first on the rough side, and after getting the answer, then you can write nicely without cutting like this. Okay, let us try B. B is NaOH plus H2SO4 Na2SO4 plus H2O. So this is for this. Okay, so here first what we'll do, first we have to do metal. Let's see, we have which metal? Sodium. Then second, what we should do, non-metal. No, non-metal other than ONH. So we have to check whether we have a non-metal other than ONH. Okay, there is a non-metal sulfur other than ONH. So second, sulfur we have to try. Third will be oxygen. Okay, if it is there, okay, fine. Fourth will be hydrogen. So let us follow this sequence. Okay, first sodium. Okay, here sodium is 1, here sodium is 2. So if you can write 2, then both sodium will be 2, 2. Fine, sodium is done now. Now sulfur. Sulfur, this sulfur is 1 because there is no number here, no number means 1. And this sulfur is also 1. So sulfur also, it is naturally balanced. If it is disturbed, we have to check again. Now, oxygen. Oxygen. For example, this oxygen is 2 and this oxygen is 4. So 4 plus 2, 6. And here you see this oxygen is 4 and this is 1. So if you can put 2 here, then both sides will become same. We can check again. This oxygen is 2, this oxygen is 4. So 4 plus 2, 6. This oxygen is 4, this oxygen is 2. So 4 plus 2, 6. Fine. Now hydrogen. This hydrogen is 2, this hydrogen is 2, so 2 plus 2, 4, and this hydrogen is 2 plus 2, 4. Naturally, hydrogen is imbalanced. Okay, let us go for C. C is NaCl plus AgNO3, AgCl plus NaNO3. Okay. So first step, we should identify the metal in the equation. So metal, one is sodium and other one is silver. So we have two metal, sodium and silver. So anyone you can do first, no problem. But both the metal you have to finish first, then only you go to non-metal. Second, let's see what non-metal should be other than ONH. So non-metal, one is nitrogen and other is chlorine. So this two also we have to do in second step, and out of this two, which one you will do first again? Anyone, no problem, that one. Okay, third step, we should go with oxygen if it is present. Okay, oxygen is present. Then fourth step is hydrogen, but if it is present, so hydrogen is not there, so fourth step not needed. From here we'll be finishing, so we'll check one by one. Sodium here 1, this is also 1. Okay, sodium, fine. Then silver no number means 1, this also silver, also fine. Okay, next nitrogen, this nitrogen is 1 and this nitrogen also 1, fine. Chlorine, this chlorine both are 1 1, so chlorine also fine. Oxygen, this oxygen is 3, this also 3. So here nothing to do, it is balanced naturally. So sometimes like this also will be given, the equation is already balanced and they are asking to balance, so just answer same thing you can write, don't leave blank. Okay, same answer you can just copy again, that answer like that. So if you just keep like this, whether you have tried or not, so in the first case also, you write the question, then you write answer, and in the answer you put the balancing. Here you don't do the balancing. So always write and then write the balancing, because here if you just leave it and don't do anything, then that means you have not attempted. So write answer and copy the same thing again. Okay, next is number D. B ACl2 plus H2SO4 BaSO4 plus HCl. Okay, so the sequence that will follow: first step, you have to find any metal is there or not. So we have a metal, barium. Okay, only one metal. So first we have to start balancing barium. Then second is non-metal other than ONH. So one is chlorine. Then we have sulfur also, sulfur. So both we have to do in second step. Anyone you can do first. Then third step, the rule is we have to do oxygen if it is present, so we have oxygen. And fourth will be hydrogen if it is present, so we have hydrogen. Okay, now we'll start one by one. First, barium. So this barium is 1, this also 1, so barium nothing to do, it is already balanced. Next is chlorine. Now this chlorine is 2, but this chlorine is 1, so if you put 2 here, then this chlorine is 2, this chlorine is 2, so chlorine done. Now sulfur. This sulfur is 1, this also 1, so sulfur is also balanced. Now oxygen. This oxygen is 4, but okay, this oxygen is also 4, so oxygen also no point of balancing. Hydrogen. And this hydrogen is 2, and there this hydrogen is also 2, so no point of doing balancing. Okay, I'm just doing balancing here, but I said you do balancing on the rough side, and after getting, then you write answer here. So answer you have to make it clearly. Okay. Let us try one more balancing from outside. Little difficulty level high will increase high from outside. Suppose FeS2 plus O2 Fe2O3 plus SO2. Okay, so if you want to follow the sequence here, what sequence we should follow? First step, we should identify if any metal is there or not. If there's a metal, that metal we have to do. So here metal is Fe, which is iron. Then second step, we have to go for non-metal other than ONH. So your non-metal other than ONH is your sulfur. Then third will be oxygen if it is present. Then fourth is not needed because fourth is hydrogen, but we don't have hydrogen, so this is not needed. So we will be doing up to third stage only. Okay. So let's start with iron. So this iron is 1, but this iron is 2. So to make balance, if you write 2, then this both side iron will be 2. So iron done. Now next is nitrogen. Non-metal, which is sulfur. So this sulfur is 1, and this sulfur is 2 into 2, 4. So to make this sulfur 4, simply you have to put 4. Let us check the sulfur again. This sulfur is 2, but this 2 is for both. That means this 2 you have to multiply. So 2 2 are 4. And this sulfur is also 4. So sulfur is balanced. Now there will be a problem with oxygen. Okay, here we have oxygen 2. In this we have oxygen 3. And here we have, like this you're not writing, you'll be writing on the left side if you want to write. Here your oxygen is 2, but 4 you have to multiply because this 4 is for both the atom. So 4 2 ja 8. And if you plus together, then your oxygen is coming 8, 9, 10, 11. And here is only 2. So we have a problem. Because there is no number when you put here, you'll get 11. For example, suppose if you put 5, then 5 2 ja 10. Then after 5, next number 6. So 6 2 ja 12. 11 you will not be getting. Then in that case, what you will be doing, okay, right side total is 11. So you write 11. But if you write 11, this is not 11 because it becomes 22. So what you do, you divide by 2. So I'll repeat. So if you write 11, so 11 into 2, 22. So you need half. That's why we are dividing. So now this is balanced now because this whole thing is 11. But in chemical equation, generally we don't write fraction. Now if you write fraction, I don't think teacher will give wrong, but generally the rule is we don't write fraction. Now, how to remove fraction? What you can do, the whole equation, this whole equation, you have to multiply by the denominator number that you want to remove. So here denominator is 2. So whole equation you multiply by 2. So this 2 you have to multiply in all the substance. So let us start from here. So FES2 formula you just copy. So in this 2 you multiply 2 and write whatever is coming. Now in this 11 by 2, if you multiply 2, you'll get 1102. This formula you write first, Fe2O3. Here no number means 1. So in this one, if you multiply 2, you'll get 2. Okay, SO2, let me copy. This is 4. In 4, if you multiply 2, you'll get 8. Now this is your final answer. Again, you can recheck to verify whether everything is okay or not. Iron, let us check. This iron is 4. This iron 2 into 2, 4. Fine. Double checking. Sulfur is 2, 4 ja 8. This sulfur is also 8. Oxygen is 22, and this oxygen here 6. Here 8 2 ja 16. 16 plus 22. So oxygen is also matching. But I don't think this much difficult level will be important for your exam. Just for your knowledge, we discuss like this. Also sometimes happen that you are not able to equalize because you are not getting a number. In that case, you go whatever fraction you're writing, you just whatever number you want that you just put, and to balance, just write divide by that something, and to make the number looking only without fraction, just multiply with suitable number so that you'll get so that you can remove the fraction. Okay, today we'll be stopping here. Thank you.